Good day, class. To reinforce what you have learned so far, let us now proceed with the sample problems about rectilinear motion. So problem 1, the position of a particle moving along a straight line is defined by the relation x is equal to t raised to 3 minus 6 times t raised to 2 minus 15t plus 40, where x is in feet and t is in seconds. So we are given the equation of the motion of a particle na in terms of position, and then we're required to solve for these four requirements: A, B, C, and D. So for the first requirement is the time at which the velocity is 0. Then the second requirement is the position and distance traveled by the particle at that time. So which means na isolve natong position and distance using the value of time t na nakuha nato sa first requirement. And then the third requirement is to solve for the acceleration using also the value of time t na nakuha nato sa first requirement. And lastly is the distance traveled by the particle from 4 seconds to 6 seconds. So in our solution, let's write the given equation. And then we also list down the requirements. So the first requirement is t at velocity is equal to 0. And then the second requirement is position and distance using the value of t from the first requirement. Then the third requirement is A, or acceleration, using again the time t that we obtained from the first requirement. And then lastly is the distance d from 4 seconds to 6 seconds. So let's start with the first requirement, or the time at which velocity is equal to 0. So in order to set the velocity equal to 0 and to solve for the time at which v is equal to 0, we make use of the given equation of position. Okay, so this is the given equation of position, and what we will do here is to make use of this one by applying calculus in order to get the equation for velocity. So we just take the derivative of position with respect to time, and this will give us the equation for velocity. So with the equation now for velocity, we can set the velocity equal to 0 so that we can solve for the target variable, which is time t, at which velocity is equal to 0. So after setting velocity equal to 0, we can now have this quadratic equation, and then by quadratic formula, we can solve two values of time. So one is negative 1 second, sorry. So which means na absurd because there's no such thing as negative time. And then ang isa ka value is 5 seconds, which is our final answer for the first requirement. Okay, let's proceed to second requirement, which is position and distance using the value of time t that we obtained from A, and that is t is equal to 5 seconds. So again, we make use of the equation or given equation of the problem, and we just substitute 5 seconds in order to solve for the position of the particle at time is equal to 5 seconds. So now in this expression or equation class, take note that I use a subscript 5 to variable x to denote that what we're referring here is a position of the particle from the reference at time is equal to 5 seconds. Okay, so x sub 5, when we simplify, is just equal to negative 60 feet. So take note that position is a vector quantity. Therefore, in our final answer, we must include the signs or the direction in our as a result. Okay, so this is the answer for the second requirement na position. And then next, we are going to compute for the distance. So before we compute for the distance, we have also to emphasize na there is a possibility na mag-back and forth ang particle. Take note that in distance class, we are computing the total length of travel. Therefore, we must consider also the back and forth. So in order to determine those back and forth, we have to take note that The change in direction of the particle's motion can be determined by investigating those instances in where velocity is equal to 0. So what we're going to do is to investigate from 0 to 5 seconds kung within ba sa kana na time interval, naghunong ba ang particle. Because pag maghunong ang particle or ang body, when it momentarily stops, that's the time na mag-change siya og direction. So kana ang signal nato na nag-change og direction ang particle. And then we can draw an accurate na drawing or plot so that we can compute the distance. So let's take this as an example to emphasize that point of change, about change in direction. So this is a previous example sa atong lesson. And let's say that the particle travels from point A to point B and then from point B to point C. So based sa kanina situation class, in order for the particle to change its direction diri sa point B, the particle must slow down as it travels from point A to point B. So maginahinay na siya og move until na mag-stop siya diri sa point B. And then when it stops, ang pag-stop niya is just momentarily. And after niya mag-stop class, that's the time na mag-change siya og direction. And then mag-move na pud siya sa bag-o na direction from point B to point C. Okay, so take note that when a particle will change the direction, the particle decelerates or slow down, then momentarily stops, then changes its direction, and then ang iyahang movement is padulong na sa bag-ong direction. Actually, makita ninyo ni siya sa real life such as in NBA games, in where a player made a step back na move. So when a player, initially the player moves forward, and then momentarily stop siya, and then he made a step back, and then shoot the ball. So that's an example na before siya nag-change of direction, there is actually a momentary stop na nahitabo before siya na-create or nag-made og step back. Okay, so that's an example sa real life. Okay, so now let's go back to our sample problem 1. So regarding sa pag-solve nato sa distance sa second requirement. So in order to investigate those instances na mag-stop ang particle, we have to use the equation na nakuha nato for velocity, which is nakuha nato sa ato ang solution for requirement A. Okay, so making use of this equation, we just have to substitute the value of time na 0 seconds, 0 second, 1 second, 2, 3, 4, 5 seconds. Okay, so isa-isaw na to siya substitute. We will be able to obtain kaning value sa second column sa velocity. And these are the values. And as we investigate the values from 0 to 5 seconds, since kaniman ang time interval natong concern from 0 to 5, we can see now in between walay 0 na velocity. So that means that the particle is just moving in one direction, and as showed here, ang sign is negative. So initially, the particle is just moving sa negative direction, and then nag-stop siya at 5 seconds. Okay, so from 0 to 5 seconds, ang motion lang niya is one way lang, which is directed to the negative direction. Okay, so we can conclude that within 0 to 5 seconds, there is no change in direction. And then, ang next nato na buhaton is to make a drawing or to plot it para mas clear ang ato ang pag-solve sa distance. So, at t is equal to 0 seconds, ang ato i-compute class is ang iyang position. No? Kung asa siya nakalocate at time is equal to 0. So, we denote its position at time is equal to 0 by x sub 0. So, using the given equation, i-substitute lang nato ang time is equal to 0, and we can get the value for that position equal to positive 40 feet. Okay, so kung i-plot na nato siya, and we set the reference at x is equal to 0 feet, and then ang direction sa right is positive while sa left is negative, we can plot na kaning initial niya na position or position niya at time is equal to 0 is mao ni siya ang drawing. No, positive 40 feet or 40 feet na pa-right gikan sa reference. While ang iyang position class at time is equal to 5 seconds, nakuha naman natong value and that is negative 60 feet. So, kung i-plot nato siya, that is 60 feet to the left or 60 feet from the reference no and directed to the left. Okay, so mao ni siya. The next, ang buhaton nato class is to compute now the distance. So, we have already concluded na walay change sa direction and that the body or particle from 0 seconds to 5 seconds, one way lang ang direction. So, walay nahitabo na back and forth. So, that means na kung i-drawing nato ang direction sa iyang motion, so one way lang na padulong sa left. And so, ang distance class is just the length of this travel path. And based now sa geometry ani class, we can write the equation for the distance required in this second requirement. So we can write d sub 0 to 5 seconds is just equal to the absolute value of x sub 0 plus absolute value of x sub 5. Okay, so simplifying, we can have the value of the required distance equal to 100 feet. Okay, so take note class na pa mag-create ta og equation sa distance based diri sa atong gibuhat no, nagdepende ta sa geometry na atong na-create. And then take note na scalar man ni siya, that's why atong final answer should carry a positive sign. Okay, so this is the final answer for the second requirement. Let's proceed now to the third requirement. So the third requirement is to compute for the acceleration at time t. So ang time t na gamiton nato diri is katong value sa first na requirement. Okay, so that is t is equal to 5 seconds. So first, before we can have the value of the acceleration, kailangan nato ang equation sa acceleration. So gamitan nato atong nakuha na equation for velocity and then atong i-set ang velocity or i-kuha na ang derivative niya with respect to time t so that we can get the equation for acceleration or instantaneous acceleration. So our a is equal to 6t minus 12. So using now this equation, we can now substitute the time na equal to 5 seconds to get the value of a sub 5. Okay, so our a sub 5 now is equal to positive 18 feet. So take note again class that I use a subscript na 5 to denote that the value of acceleration nato ang ginasolve is about acceleration at time t is equal to 5 seconds. And since pod ang problem is wala na specify whether average or instantaneous acceleration, so ang ato ang assumption diretso ang ginapa-compute is instantaneous. So that is the reason na nganong ang i-consider lang nato is just an instant na time is equal to 5 seconds. Okay, so ang last requirement is the distance from 4 to 6 seconds. So take note class, pag nag-compute tag distance, so total length of travel, we have to consider also the back and forth. So mga back and forths, makonsider nato siya kung atong investigate kung asa na mga time nag-zero ang velocity. Because kung zero ang velocity or nag-momentarily stop ang body, kana ang signal na mag-change siya og direction. So, to investigate those times na zero ang velocity, let's make use again sa equation sa velocity na na-obtain nato previously. Okay, so mao niya equation na nakuha nato previously. And then, let's create a table na different values of velocity from 0 to 6 seconds. Okay, so from 0 to 6 seconds, mao niya ato ang ma-create na table. And take note na nakuha na po nato ni na table from 0 to 5 seconds and then ato alang gidungagan ng isa ka row for time is equal to 6 seconds in where ang corresponding velocity is positive 21 feet per second. And just a tip class sa inyong calculator, pwede ninyo i-explore ang table mode so that you can create this mas dali ang pag-create ninyo sa ingani na table. So, by using table mode, you can just input this equation sa inyong calculator and then mag-specify mo mga input na values from 0 to 6 seconds. Then, ang calculator na amuhatag og mga corresponding values based sa inyong input. Okay, so now class, based sa ato ang nakuha na values, since ang target man nato is distance from 4 to 6 seconds, so investigate nato ang yung velocity from within 4 to 6 seconds. So, makita nato diri na at 4 seconds, nag-travel siya directed sa negative direction, and then nag-stop siya momentarily sa 5 seconds, and then nagbalik siya o move at time is equal to 6 seconds, pero this time, moving to the positive direction na siya. So, based sa result, na ay change of direction na nahitabo, so therefore, we have to consider also that change of direction sa pag-compute nato sa distance. So, in order to plot clearly, kailangan nato i-consider ang position sa particle during or at time 4 seconds, 5 seconds, and 6 seconds. So, ang pwede nato buhaton class is gamitan nato balik ang given equation for position. And then again, pwede mo magamit og table mode to also compute the position of the particle from from values na time is equal to 0 up to 6 seconds. So, using the table mode, muhatag na siya og values of position na corresponding sa inyong mga input na time. So, ang concern nato diri class is katong time na 4 to 6 seconds. So, ang position niya at 4 seconds is negative 52 feet. Then, at time is equal to 6 seconds, that is negative 50 feet. Katong negative 60, na-compute nato ni siya a while ago. So, kani siya is, kaning tulo, i-consider nato ni sa atong plot. So, kung gamitan nato ang previous nato na drawing, pwede nato i-superimpose ang katong result sa 4 seconds and sa 6 seconds. So, at 4 seconds, ang particle is located 52 feet from the reference and direction niya is sa left side. And then at 6 seconds, ang position sa particle is negative 50 feet. Next, let's draw the direction of motion from 4 to 5 seconds first. Okay, so from 4 to 5 seconds lang muna ito unahon since nag-change man siya direction, no? Diri sa 5 seconds. Okay, so from 4 to 5, ang direction is negative. So, mao ni iyahang direction sa iyang motion and the total distance traveled within 4 to 5 seconds is just the length of this line. Then we can represent that distance as d sub 4 to 5. And then from 5 seconds to 6 seconds, nag-travel ang particle, balik, naglihok na po siya balik, no? Pero ang direction niya is pa-positive. So we can represent the distance from 5 to 6 seconds as d sub 5 to 6. So based now on our geometry sa drawing nato, we can write the equation for the total distance from 4 to 6 seconds na equal lang siya sa sum aning duha. So, distance sub 4 to 6 is just equal to d sub 4 to 5 plus d sub 5 to 6. Okay, so using now this equation for the total distance, ang buhaton nato next is isolve nato isa-isa. So, unahon nato ning d sub 4 to 5. So, for d sub 4 to 5, this is just equal to d sub 5 minus d sub 4. So, ang basis nato ani class is based ato ang geometry yapon. So, kaning d sub 5 is just equal sa absolute value sa x sub 5. So, kani siya na ang distance is absolute value lang aning x sub 5 and then minus x sub 4 which is absolute value aning. Okay, so take note that the distance of a particle from a reference is equal lang sa absolute value of its position. Okay, so kung ato pong imagine class na i-minus na to x sub 5 o x sub 4, ang mabilin is kaning distance na 4 to 5. Okay, so balik ta sa ato equation, Let us substitute the needed values, and then let's apply the absolute values. Okay, so 60 minus 52, ang ato ang distance from 4 to 5 na na-travel sa particle is equal to 8 feet. Then next, let's compute the distance traveled by the particle from 5 to 6. Okay, so that is equal to d sub 5 minus d sub 6, or pwede po isulat nato as absolute value of x sub 5 minus x sub 6. So katong tanawon sa itong geometry class, kung i-minus nato no ang absolute value sa x sub 5 at absolute value sa x sub 6, ang mabilin is kaning distance na 5 to 6. Okay, so by substituting the needed values, we can compute that d sub 5 to 6 is equal lang sa 10 feet. So, atong final answer class for the total distance from 4 to 6 seconds is just equal to the sum of these two results, and that is equal to 18 feet. So, this is our final answer for the last requirement. And just in case lang napakomputon ka sa displacement from 4 to 6 seconds, so ang drawing niya is, i-connect lang nimo ang initial position to final position. So, dili na nato i-consider iyang position at 5 seconds. Okay, so again, ang displacement, initial and final position lang ang gina-consider. Okay, so take note that displacement is equal to final position minus initial position. So based sa kanina problem, ang displacement from 4 to 6 seconds is equal to x sub 6 minus x sub 4. So kung ato i-substitute ang mga values, ang makuha nato na displacement from 4 to 6 seconds is equal to positive 2 feet or 2 feet directed to the right. So take note of the difference sa ilang values and also sa way sa ilang pag-solve. Okay, so this is sample problem 1. For sample problem 2, please refer to the next part of this lecture.